Okay, right then. Today we are going to discuss on water. Right, last day we finished discussing that unit 1 part and elemental composition of unit 2. Today we are going to go through water part. Right, kind of an important part, essential part. The reason for the importance is that okay. Now this exam or the new syllabus is running from 2019 onwards. Now till 2025 the exams have been held. Okay, so for these 6 years water hasn't been tested in question paper, either MCQ or essay or SCQ. It hasn't been tested. So actually if it when it's come to the water essay or to the come to the essays of biology, if we ask from a student right now, you might not be that much as familiar with that content, but when you ask from a guy that is closer to the exam, it is from a elder student, right? For it means now you are just there in the level who is doing second shy or maybe third shy. Okay, if you ask from a student what is the essay or the most easy essay to write in the syllabus, he or she will definitely say the water essay. The point behind that is now such essays are not easily tested in the exam because they are very easy. But mind you, the syllabus runs for a certain particular time period. Now the earlier syllabus, now 2019, the new syllabus, before the prior to the new syllabus, the earlier syllabus which ran for from 2010 to 2018. Okay, so it included that the plasma membrane essay at the last A-level exam, 2018, the end of the syllabus, right? From 2019 A-level, the new syllabus began to give in the exam. No? So 2018, they gave the plasma membrane, a very small essay. Likewise, this water essay might be there in the end of the syllabus. Maybe I think now you are facing 2028 A-level exam. No? Might be 2028, 2029 or 30, maybe the end of this syllabus, right? So then you have a great opportunity, or you have a good kind of intention of getting this water essay. So it's that's in that aspect this part is very important. Okay, right? And MCQs also you can get it in the exam, maybe I'm not sure. And also maybe in the SCQ part you will be tested, right? Okay, so we'll start the water part. Now we are in the unit 2. We are in the unit 2, and in the unit 2 we have completed the elemental composition, right? Now point number 2, today we are discussing the point number 2 and 3. Chemical property of water important in life is the point number 2. Point 2, chemical properties water important in life, right? Point number 2, unit number 2, right? Okay, so write down the point number 2, right? Chemical properties of water important in life. Okay, now start writing. Water is a vital inorganic molecule. First point, water is a vital inorganic molecule. Water is a vital inorganic molecule. Next point, right? Water is important. Water is important. Water is important due to following reasons. Water is important due to following reasons. Following reasons. There are two reasons. Water is important due to following reasons. There are two reasons. Number 1, write down. Vital chemical constituent vital chemical constituent, vital chemical constituent of living cell, vital chemical constituent of living cell. Number 2, provides a biological medium for, provides a biological medium for, provides a biological medium for all organisms, for all organisms, provides a biological medium for all organisms. That is the second import, right? So in the first one, right, underline chemical constituent, underline the phrase chemical constituent. Then second reason, underline biological medium, right? Underline biological medium. Right. Now write down, write down just as kind of a subtopic, right? Chemical structure of water molecule. Write down chemical structure of water molecule. Chemical structure of water molecule. Chemical structure of water molecule. So write down first one. Water molecule is a small. We'll discuss it after writing, right? Water molecule is a small, comma, polar, 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 and angular molecule, and angular molecule. Water molecule is a small, comma, polar, and angular molecule. Right? First one done. Second statement. Polarity is an, polarity is an, polarity is an, polarity is an uneven charge distribution, uneven charge distribution, uneven charge distribution within a molecule, within a molecule. So in the first point, underline small, then separately polar, then separately angular. Those three need to be not highlight, underline separately. Small, polar, and angular, you need to underline them separately, right? In the second one, second point, you have to underline uneven charge distribution. Uneven charge distribution, underline that uneven charge distribution, right? Then write down the next point. In water molecule, in water molecule, in water molecule, oxygen atom is, oxygen atom is, oxygen atom is, oxygen atom is slightly negative, slightly negative, slightly negative. Oxygen atom is slightly negative, and hydrogen atom is, and hydrogen atom is, and hydrogen atom is slightly positive, slightly positive, and hydrogen atom is slightly positive, right? So underline slightly negative and slightly positive, those two, slightly negative and slightly positive, underline those two. Then write down weak attractions between, weak attractions between, weak attractions between slightly polar hydrogen atom, slightly polar hydrogen atom, slightly polar hydrogen atom of 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 one water molecule, one water molecule, one water molecule and the slightly polar atom, sorry, and slightly polar oxygen atom and slightly polar oxygen atom, slightly polar oxygen atom of adjacent water molecule, adjacent water molecule, adjacent water molecule are known as, are known as, are known as hydrogen bonds, are known as hydrogen bonds, hydrogen bonds, right? So underline weak attractions, then hydrogen bonds, those two places, right? Weak attractions and hydrogen bonds underline, right? Then write down next point. These hydrogen bonds, these hydrogen bonds, these hydrogen bonds play a major role, play a major role, play a major role in maintaining, in maintaining, in maintaining all the properties of water, all the properties of water, all the properties of water. Play a major role in maintaining all the properties of water. So underline all the properties of water, all the properties of water underline, right? All the properties of water. Right. Then write down. Right. The properties of water arise due to, the properties of water arise due to, the properties of water arise due to hydrogen atoms between, hydrogen atoms between, the properties of water arise due to hydrogen bonds between different water molecules, different water molecules, different water molecules. Then next point write down. When the water is in liquid form, when the water is in liquid form, when the water is in liquid form, its hydrogen bonds, its hydrogen bonds, its hydrogen bonds are very fragile, are very fragile, are very fragile. So in the earlier statement that the properties of water arise due to the hydrogen bonds between different water molecules, they are underlying hydrogen bonds, right? They are underlying hydrogen bonds. And then in the next point, underline liquid form and fragile, very fragile. Liquid form and very fragile, underline those two. Liquid form and very fragile. Liquid form and very fragile, right? Okay. Liquid form and very fragile. The next point, hydrogen bonds, hydrogen bonds, hydrogen bonds form, 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 comma, break, 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 and reform, and reform, and reform with great frequency, with great frequency. Hydrogen bonds form, break, and reform with great frequency. So great frequency underline. Right. Now we have plenty to talk with. plenty to discuss with. Now come here, come to the board, right? Okay. Okay. Now we have discussed of the structure and the chemical arrangement of the water molecule, right? We have discussed. Now it's time to take the clear understanding about it, right? Okay. Now water, when you say water, right? When you say water, all you know now, these are all level stuffs, right? Okay. When you know water, when it comes to water, water means what is the chemical formula, right? It's the H2O, right? Chemical formula is H2O, right? H2O, right? Okay. It means dihydrogen and monoxide. It means two hydrogen atoms and a single oxygen atom combines to form H2O. It's simple, right? Okay. Then what is important there? The structural arrangement. Now oxygen atom is like this, and it is bound to two hydrogen atoms. It is bound to two hydrogen atoms. Two hydrogen atoms, right? Okay. Now keep the intentions and attentions towards this, right? Okay. Don't go away, right? Okay. Then when come to oxygen, there are pair of valence electrons, right? Pair of valence electrons, right? In order to complete oxygen's valency, right? You have to complete the valency. Therefore, two pair of valence electrons are there. It's okay, right? It's okay. And you can see there is an angle. There is an angle between oxygen and two hydrogen atoms. There's an angle. The way how the hydrogen are attached to the oxygen atom, there's an angle. If we take that angle as theta, then theta equals to 104.5 degrees. 104.5 degrees. 104.5 degrees, right? Okay. That's why we name this molecule as angular. Angular. Now, earlier mentioned in the note as there is that the water molecule is smaller. How you know it's small? It's very large now, right? It's larger than my head even, right? How can this be small? Now this is the graphical representation kind of thing. Now imagine once you drink water, can you see water molecules? Have you ever seen water molecules while you're drinking water? No, never. What is the size of the water molecule, right? You will be amazed, right? You will be amazed, right? It is around 2.7 into 10 to the power minus 10 meters. Oh my god, the size, right? Okay, very small. It means we can represent it as 0.27 nanometers, right? You can imagine nanometer range, even that is 0.27 nanometers, right? Really small, right? Very small. Okay, now you know it's a small molecule and it's an angular molecule. Now come to the very important concept, right? Okay, that is the electronegativity. You know these things, right? These are simple science, right? In O level, right? You have discussed those things. Electronegativity, right? Not negative, electronegativity, right? Okay, electronegativity. Now electronegativity. Okay, what is electronegativity? Electronegativity is the force of electron attraction towards a certain particular atom, right? Attraction of the power of attracting electrons, right? Okay. Now when it is come to electronegativity, there is a scale known as Pauling scale. You will get to know those things in chemistry. You might have already gone through those parts, right? Early chemistry, right? Simple chemistry. So oxygen electronegativity is 3.5. It means the force it's apply on electrons is around 3.5, kind of such kind of a thing. Hydrogen, it is 2.1. Now you can see a clear gap between those two, right? You can see a clear gap between those two. Now what happens, right? Okay, oxygen pulls electron towards himself with a greater force when compared to the hydrogen, right? Here also the same with this bond, and here also same, right? Then what happened as a result of that? more electrons are associated around the oxygen atom. More electrons are associated around the oxygen atom when relative to hydrogen atom is less. Associated with hydrogen is very less, right? Very less. Okay. Now see, one this represent that electrons are closer to oxygen. That is not representing, or it's not it's not saying, it's not indicating that oxygen is getting those electrons. No, no, no. What it's saying, what is suggesting it, that electrons are much more closer with oxygen, right? More electrons are closer with oxygen, right? So oxygen getting a, not a negative, you can't say it's a complete negative charge, right? Okay, oxygen is getting a, oxygen is getting a what? Oxygen is getting a, right? It's getting a what? A slight negative charge, slight negative, right? Slight negativity. Then hydrogen, meanwhile, opposite of that, slight positive charge. Now we are okay. Now we are getting the thing. Now similarly, here also slightly negative. Here then slightly positive. Nice, nice, right? That is how the charge distribution can be seen within this molecule. Okay, 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 right? Then once again, oxygen here, two hydrogens here, two hydrogens, slightly positive, right? Slightly negative, slightly negative. You can see uneven charge distribution. Here positive, positive, here negative, 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 positive, positive, negative. You can see a kind of uneven distribution. Not all are not positive, and neither positive nor negative. It's a mixture. Positive, negative, negative, positive, positive, negative, positive, negative. Likewise, that kind of a mixture. The distribution is not even. If it is a single charge, it's even. But both charges have been distributed within the molecule, so it is an uneven charge distribution. Okay, that is why we name that water is a polar molecule. Polarity arises due to this charge distribution, and that charge distribution is uneven. Got that point clearly? Nice, perfect. Okay, so that is how the water molecule looks like, and the slight negativity, slight positivity, then how that is created. Then there's an angular arrangement, and it is very small because it's around 0.27 nanometers, and this is polar due to its charge distribution. Take this down. Quickly note this down. Okay. Okay, then we have to go through the hydrogen bonding here in the water molecule. Okay, right? Now come here, right? Okay, now this is the water molecule. Okay, oxygen, then two hydrogens, then here pair of valence electrons, slightly negative, slightly negative, slightly positive, slightly positive, right? Now see, here is another water molecule, oxygen, hydrogen and oxygen, pair of valence electrons, slightly negative, slightly negative, slightly positive, slightly positive. Here is another water molecule with pair of valence electrons, then hydrogen, then here hydrogen. Then here there's another hydrogen atom, another water molecule like this. Okay, hydrogen, oxygen, hydrogen, oxygen. Then there's another water molecule, oxygen, oxygen, then hydrogen, then hydrogen. Okay. Now when come to the bonding, now slightly positive. Positive always go with negative, right? Not negative, negative, positive, neither negative, negative, no. Positive, positive, always positive with negative. Now here, this hydrogen slightly positive one with this slightly negative oxygen. Then this slightly negative oxygen with this slightly positive hydrogen. This slightly negative oxygen with slightly positive hydrogen. So this slightly positive hydrogen is slightly negative oxygen, right? Okay. Then slightly positive here, slightly positive. I have missed that. Slightly negative here, slightly positive, slightly positive, slightly negative, slightly negative. Okay. Then slightly positive, slightly positive, slightly negative, slightly negative. Okay. Now you can see there is a single one water molecule, single water molecule there in the middle. Then a single water molecule can make four hydrogen bonds with another four different water molecules. So a single water molecule can make four different hydrogen bonds. Can make four hydrogen bonds, right? Can make four hydrogen bonds. A single water molecule can make four hydrogen bonds. So this is a kind of a weak attraction, not a strong attraction. I will explain it, right? So these are known as right, okay, these are known as hydrogen bonds, right? So one water molecule have can make four hydrogen bonds with another four water molecules, right? Okay, complete it. right? That is how the arrangement is there. A single water molecule can make 4 hydrogen bonds, and it means 4 different other water molecules can bind with the water molecule, right? Okay. Now, okay. Now imagine, now this is water, right? This is not vodka, this is water, right? Okay. So if I take some water, now its water is stable in the water bottle, right? Okay. Right? Water bottle, stable. Okay. Now this is a water bottle and it's stable, right? Water is stable in the bottle. Now I'm uh, kind of pouring water into this piece of cloth. Now you can see water drops onto it, right? Okay. Water falls, right? Then what happened? Hydrogen bonds get break, right? Break and get into the piece of cloth, right? Okay. Then in the cloth, water hydrogen bonds are forming and they are stabilized. Then what I will do, I will, right, wipe this out, right? Okay. I will wipe this out. You can see water dropping from this piece of paper, right? Piece of cloth, right? Water dropping, right? You can see water dropping, right? Water is falling. Once I wipe it, water is falling from the piece of cloth, right? Okay, right. Then what happened? Water falls on the floor. Then I will take a broom and I will sweep it, right? Okay. Then what happens? Now you see water gets stabilized on different locations, and then once the place is changing, that hydrogen bond break. Then once again at a certain particular place, reform, break, reform, break, reform. So it means this is happening in the what state? This is happening in the liquid state, right? This is happening in the liquid state, right? Okay. So there are three states, right? There are three states in water. There are three states in water. You know, your water has three states. One is H2O, the most known one, H2O liquid form. We named it that as liquid water, right? Liquid water. Okay. Then there is another state known as H2O gas state, gaseous one. That is water vapor. Then once again there is another state, that is H2O solid, that is ice, right? Ice state, right? Okay. So out of those states, we can cut down the water vapors because the attractions are very weak as it is an air, in type of an air. So weak, very weak attraction. Then come to ice. So we have to take ice in its condition. It means its condition is 0 Celsius. So if imagine now the surrounding is 0 Celsius, then at that 0 Celsius, ice is more hard. Like it's hard as bricks, right? Hard as stones. If we take ice cube, we can kill a person even, right? Not at room temperature because ice is melting, no. But when if the room or the surrounding is like, just imagine now this room is a freezer, then what will happen? Ice is stabilized at 0 Celsius. Then we even can kill a person, and we can do any kind of thing that we are doing with this hard stone, right? Okay, that's that kind of strength is there in ice, right? But liquid water, you know, liquid water, what is happening? Its hydrogen bonds are fragile. We have written that, we have completed in the note. Fragile, it means break, form, reform, break, form, reform. Likewise, the process is happening. So fragility is found in the liquid state, mind you, right? Not in the solid state. Fragility is found. So therefore, a great frequency, the bond forming, reforming, breaking, forming, reforming, breaking, that is happening in a great frequency. You have to understand it also, right? So finally, what you have to understand, hydrogen bonds at liquid state are hydrogen bonds in this state. It means in liquid water are very weak attractions, right? Very weak. Hydrogen bonds are very weak. That can be what kind of it's proved in liquid water state, the way the water changes its locations that I just show you, right? Okay. That's what happening. Okay, now it's okay. Now come to the point number 3. Point number 2 is over. Then come to point number 3. 0.3 physical properties of water important in life. Physical properties of water important in life, right? So write down, there are 4 major properties of water. There are 4 major properties of water. 4 major properties of water to maintain life on earth. There are 4 major properties of water to maintain life on earth. Number 1, write down one by one, right? You have to write down one by one. One by one, you have to write down. Number 1, cohesive behavior. Cohesive behavior, right? Second one, ability to moderate temperature. Third one, expansion upon freezing. Finally, fourth one, versatility as a solvent. Versatility as a solvent, right? You have to write these 4. These are the 4 main physical properties, right? This will be given in essays, right? Very vitally, you have to keep in mind cohesive behavior, ability to moderate temperature, expansion upon freezing, and versatility as a solvent. Right. So once again, put a subtopic as cohesive behavior. Cohesive behavior, right? Put a subtopic as cohesive behavior and write down first point. Okay. Attraction between water molecules due to hydrogen bonding is known as cohesion. Attraction between water molecules due to hydrogen bonding is known as cohesion. Then second one, write down, attraction between water molecules and other substances are known as addition. Right. So first point, underline cohesion, and also underline between water molecules, right? Then the second point, underline water molecules and other substances, underline Then once again underline addition, addition. Once again underline addition. Right. Okay. Then write down both of the above properties of water. Both of the above properties of water. Both of the above properties of water both of the above properties of water allow 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 it to act as allow it to act as a transport medium, a transport medium, act as a transport medium. Right. Then highlight the transport medium. Highlight the phrase transport medium. Right. Okay. Due to cohesion between, write down the next point. Due to cohesion between water molecules, water molecules, water and dissolved substances, water and dissolved substances such as minerals are minerals are minerals are transported as transported as transported as a continuous column, a continuous column through xylem, through xylem, through xylem against gravity, against gravity, against gravity, against gravity. Right. So underline against gravity and also cohesion. The word phrase cohesion, right? Underline cohesion and also against gravity. Then write down next point. Addition between addition between addition between water molecules and water molecules and water molecules and cell walls cell walls cell walls also helps in also helps in also helps in conduction of water conduction of water conduction of water and dissolved substances dissolved substances dissolved substances, right? So underline addition. Then water has the next point. Water has a high surface tension. Water has a high surface tension. Highlight high surface tension. Highlight, so don't highlight, underline, right? Underline high surface tension. That I'm always telling to underline, highlight. Sometimes I take say highlight. The reason that in revision I'm always telling them to highlight because they only they are for their notes will available for 10 months or maximum of 10 months now. The express revision, that the revision we are doing after the results are released, is a kind of express revision, right, for 4 months, right? Then that those revisions are only 4 months or 10 months maximum, right? So then highlighting might not affect the note, but for you this note you need to keep it with you for 2.5 years, right? So then we need to be alert or be just kind of carefully arrange the note and be careful on the preservation of the note, right? If that highlighting can damage the note, right? Okay, may can damage because the highlights may be just can be there in the other side, or even might disrupt your reading process. So underline is no issue. You have to use a red pen to underline, right? Okay. This ability, next point, this ability is given to water molecules. This ability is given to water molecules. This ability is given to water molecules due to cohesion between due to cohesion between water molecules. Cohesion between water molecules. Next point. It therefore in aquatic system, therefore in aquatic system, therefore in aquatic system, upper surface water molecules, upper surface water molecules are attracted, are attracted, are attracted by lower surface molecules, lower surface molecules, lower surface molecules, and it forms a and it forms a and it forms a water film, water film, water film. So this ability is given to water molecules due to cohesion. So underline cohesion there in that statement. And the new statement, the written one, in an aquatic system, upper surface water molecules are attracted by lower surface molecule and it is forming a water film. So underline water film, right? Water film. So then the next point, small insects, small insects, small insects can walk on the can walk on the surface of a pond. Walk on the surface of a pond. Surface of a pond. Right? So write down the example of the insect. Water skaters. That is the example. Water skaters. Water skaters. Right. Then second one. Okay, Aaron. Prior to second one, we'll discuss about the first one. Right. Okay. Now we have written some important facts. Now come on. Right. Okay. Now this is the vascular tissue. It may be xylem or phloem. Vascular tissue and its wall, right? Cellulose wall, right? Okay. Then water molecules are arranged like this. Okay. Water molecules are arranged like this. Water molecules are arranged like this. So water molecules with each other, they are attached or they are attracted since they have forming bonds. Then water molecules along with cellulose cell walls, they are forming bonds. Bonds are represented like this. So these bonds are because of addition, because water and non-water water and cellulose, right? Then these bonds are because of cohesion, because they are like it means water and water cohesion because of hydrogen bonding, right? Okay. So gravity is downwards and always pulling water downwards, right? But against gravity, water is transporting upward, right? So water transport upward, right? This is the direction of water transporting upward. How it happens, right? How can it happen? Now imagine this water column, right? This constant water column is maintained as a result of water binding each by each, right? Water is attracted and bounded to all the water molecules one by one due to cohesion. And also water is not dropping because they are attached to the walls, right? They are attached to the cellulose walls, then therefore they are kind of fixed there, right? They are arranged in a neat manner that they are not moving downwards, right? Okay, they are not moving downwards. Okay, so this both addition and cohesion helps in transportation, right? Those addition and both cohesion helps in the transportation of substance, maybe water, and water, the substances dissolved in water, right? All those transport through the xylem and phloem. This is vascular tissue, right? So, and this is the cellulose wall, right? I will represent this is cellulose wall, right? Okay, and this is vascular tissue. This is vascular tissue, right? This is vascular tissue. Vascular tissue. It may be xylem or phloem. Xylem or phloem, right? Vascular tissue, right? Okay, it is like this. Now the bottle is like this. Now just imagine this is my two pair of hands are the cellulose wall, and the bottle is the water molecules, right? The column of water molecules, right? So now water molecules are attached to my hands. It means water bottle is attached to my hand. The moment that my hands are released, what happened? Water falling down. Water drops, right? That will happen if, because gravity is always downwards, no? Right? Right? If someone is sleeping, might get waken up, right? Okay. So the gravity is always downwards, right? So that's why that water is falling downwards, right? Okay. And also another thing I can demonstrate is in this manner also, right? This is a series of cello tapes, right? On each one by one. So like these cello tapes are arranging, that represent how the water molecules are arranged in a column. Now here we can take one by one, right? One by one we can take. Now these are arranged in a column, constant column. Then water molecules are like that, and the cellular cell wall is arranged in this manner, right? Cellular cell wall is arranged in this manner. Now imagine, now if the cellular tapes are not bound to each other, then that column is breaking, no? Like that water molecules are attached to each other by cohesion. And also that my hands also needs, because if my hands just detach from the cellular tape, then they will fall down like this, right? Once I detach my hands, all has fallen down. That will happen to water also. So therefore both cohesion and addition are very important, right? Okay, so I hope that you have understood the addition, cohesion, and how it affects for the transportation process. Okay, how it affects for the transportation process. So that is how things are happen. It means that is how the transportation is taking place, and how addition and cohesion support it, right? Both the addition and cohesion need not only addition or not only cohesion, but also the mix, the collection of both the addition and cohesion properties are needed. You can write it down quickly, note it down quickly. Right, okay. Now we'll go through the surface tension, right? Okay. Now this is what it looks like, what is happening there, right? So this is kind of a pond. Okay, we'll demonstrate this as a pond. Okay, then what happens? Water molecules are arranged in this manner, the upper surface water molecules, right? they are bound to each other and they are arranged in this manner properly, right? Okay. Then the upper surface, beneath that there's the second water surface, or the second layer is that. Now second layer is also attached with the first layer. You can see now first and second one attaching each other, attracted, and also each one in the same layer attracted one by one attracted with another, right? Likewise, okay. This is what happening, right? This is what looks like. Now this is all because of cohesion. So what is the use of that? Now because of this attracting is form kind of a hard layer, right? A kind of a layer, right? Okay, kind of a thin film. Not all the organisms, right? Not all the organisms, like small insects, like creatures, can walk on the surface, right? Okay, can walk on this surface, right? Okay, so that is the use of benefit. We not that cats, dogs can walk on small insects, right? Small insects, they can walk, right? Okay, so this is the surface tension which is created by the cohesion, right? Note it down. Right, okay. Now I think you have completed it. Now point number 2, write down. Hurry. So write down the second one. Write the subtopic, ability to moderate temperature. Ability to moderate temperature, right? Write down first point. Water can absorb or release. Water can absorb or release. Water can absorb or release. Water can absorb or release a relatively high, a relatively high, a relatively high amount of amount of amount of heat energy by a slight change in by a slight change in its own temperature, its own temperature. So underline slight change in temperature, slight change in temperature. Then write down second point. Next point, due to the high specific heat, due to the high specific heat, due to the high specific heat, water will function as water will function as water will function as thermal buffer, thermal buffer thermal buffer in living system and aquatic bodies during the temperature fluctuations on Earth. Due to the high specific heat, water will function as thermal buffer in living systems and aquatic bodies during the temperature fluctuations on Earth. So underline high specific heat. Right. Then underline thermal buffer. Okay. Then write down, due to high heat of vaporization, with the minimum loss of water, due to high heat of vaporization, with the minimum loss of water, with the minimum loss of water, an organism can release much heat energy. This helps the organisms to cool their body surface example, prevent from overheating. Example, prevent from overheating. Then next point, write down, evaporation of sweat from human skin helps to maintain the body temperature at constant level. Underline evaporation of sweat. Then in the earlier statement, underline high heat of vaporization. Then underline minimum loss of water. Much heat energy. right? Okay, underline those things, right? Then the other point, next point, write down. Transpiration in plants. Transpiration in plants helps to cool the plant body surface. Helps to cool the plant body surface and prevent from and prevent from and prevent from becoming 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 too warm in the sunlight. Too warm in the sunlight. Too warm in the sunlight. So underline transpiration, right? Right. Now we'll go through the explanations, right? Now water, this is water, can release heat, or it can absorb heat, right? But the delta theta will be minimum. What is the reason behind that? What is the reason behind that? Okay. What is the reason behind that? Now, you know this equation, you are familiar with that. You have gone through it in the O levels. Q equals mc delta theta. C is the specific heat capacity. Specific heat capacity, right? So we can isolate what? Delta theta. Delta theta equals Q divided by mc. Here for a certain given liquid, Q and M are, sorry, Q and M are constants. Q and M are constants. Q and M are constants. Therefore, delta theta is inversely proportional to the specific heat capacity. While C is increasing means delta theta is decreasing. That is what happening in water. Now, if we take a different liquid here, like coconut oil or something like that, kerosene oil, the C value is much more less. Then delta theta will be higher. Okay, so you can write it. This is what happening in specific heat capacity. Write down. Write down quickly. Write down. Right. You have to be focused. Right. If you feel sleepy, you can have some water. Right. You can have a nap even. If you become sleepy, then sleepiness will not be there. Right. Okay. You will be relaxed and you can wake up at the early morning, right, on the following day. But don't do it during the classes, right? Okay. Right. Keep on going, right? But some guys, they even don't feel sleepy. They are working hard, right? They are working hard. Those guys will reap the success quickly, right? Okay. So that is the determination and dedication that is personal, right? That is personal, right? Okay. So you have to understand what you are doing. What you are doing. If you feel lazy, then you will be crazy. Okay. So don't be lazy. Don't take it easy. Right. Quickly note down. Right. So thermal buffer act as a thermal buffer, no? Buffer means a thing which maintain things in a constant level. Buffer means a thing that it means certain thing that maintaining or keeping thing in a certain level, right? In a constant level, buffering, right? Or maintain the temperature in a constant level, that is buffering, thermal buffering, right? So due to this specific heat, that capability has been there. Okay, right. Now, okay, now I think you have completed. Now, high heat of vaporization, when you come to that part, now imagine a very bright sunny day and you are out for uh, classes or maybe sports meet in the school, right? You're like this, okay. Okay, what will happen? Now the sunlight and heat will be there maximized, right? So maximum heat will be obtained. Then as a result, what happened, right? Okay, as a result, what happened? Lots of heat comes in. Lot of heat comes in. Imagine now you are getting 5,000 joules, right? Okay. So what happened? This heat need to be transmit outwards, right? So this heat need to be transport outward. So right. So what is the importance of water, right? What's the importance of water? Uh, just then water is evaporated in that process, right? Water is evaporated as water vapors, as sweating, right? In order with the heat releasing. So with less amount of water released, right? It has been able to release much more. Sorry, with less water, right? Okay, with less water, with minimum amount of water, right? More heat, right, is released. With minimum amount of water, more heat is releasing. Okay, that is the benefit. So imagine it may be very little amount, but if we take kerosene oil or coconut oil or any different liquid, okay, then we have to sacrifice more, that certain particular more liquid more, right, more than water, right? So that's the importance of water there, right? So keep it noted, right? Note it down. Note it down, right? right? Okay. Right. Then sweat is at water vapors. Now here sweat is what releasing. Sweat is what releasing. Okay. Done. Then move into the point number 3. Write down expansion upon freezing. Expansion upon freezing as a subtopic. Write down expansion upon freezing. Right. Okay. Write down. Write down. Generally, 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 in an increase in temperature, in an increase in temperature, in an increase in temperature of any substance, of any substance, of any substance reduces, reduces, reduces their density, their density, their density, and on the other hand, and on the other hand, and on the other hand, in a decrease in temperature, in a decrease in temperature, in a decrease in temperature, increases their density, increases their density, increases their density. Right? Then write down next point. So underline, right? Increase in temperature, reduce density. Decrease in temperature, increase density. Underline it, right? Okay. So increase in temperature, reduce density. Decrease in temperature, increase density. Then next point, write down. When the temperature of water falls, when the temperature of water falls, when the temperature of water falls below 4 Celsius, below 4 Celsius, it begins to freeze. It begins to freeze. It begins to freeze. It begins to freeze and forms, and forms, and forms a crystalline lattice, a crystalline lattice, a crystalline lattice called, called ice cubes, ice cubes, ice cubes. Right. Then underline below Celsius 4. Below Celsius 4. Underline the place below Celsius 4. Then ice. Underline ice. Right. Ice. Then write down. Water has the maximum density at. Water has the maximum density at 4 Celsius. 4 Celsius. Water has the maximum density at 4 Celsius. So underline 4 Celsius. Right. Maximum density at 4 Celsius. Then write down. Next point. Ice floats on the surface of water bodies. Then so ice ice floats on the surface of water bodies, right? Okay. Then write down next one. It is an important property. Right. It is important property of water in polar regions. Of water in polar regions. It's an important property of water in polar regions where organisms, where organisms, where organisms in aquatic bodies, in aquatic bodies can survive during the winter during the winter right. Understand what is here, right? So understand what is there, right? Okay, now see here. Now in a normal liquid, what happens in a normal liquid? Now we take density here for the y-axis. The rho is the kind of a symbol using, and temperature we are using theta. And normally what is the graph? Graph is like this. The density with the increase in temperature, density decreases, right? So write down this is normal substances, right? Normal substances. This is what happening. But for water, that is somewhat special. Now draw that graph. That is for normal substances. That for normal substances. That for normal substances. Right. Okay. Now when come to water, right? Okay, the same thing, but there's some sort of difference there, right? Okay. This the graph, maybe you can just sorry, you can just draw it like this even, right? Kind of this manner even is the variation, maybe like this or maybe this, right? Okay. Better if you draw like this, right? Better if you draw like this, sorry, right? That is the earlier one is not incorrect, but maybe it's dropping furthermore. Slide now the mean. Now these are two meanings now, here and this one. So here what happening when the temperature further increases, the more the slope is there, right? Here it's not like that. So therefore just if you have draw the earlier one, just if you have drawn it in pen, just apex it and just draw this one, right? If you have drawn from the pencil, just erase and make the new one, right? The dropping is the variation of the density is like this. Okay, now the next one, next with the water, right? Next with the water. Now next with the water, what is happening with water, right? Now what is happening with water? The same thing, not the same thing, but here y-axis density represented by rho, then right, then t-axis, sorry, not t, x-axis temperature by theta. Okay, now here 0 Celsius, and here I will denote 4 Celsius, right? And rest. Okay, and this is the maximum value that water can get, rho max. Okay, then here it comes the rho ice, density of ice. Okay, now the graph I'm drawing. Now at 4 Celsius, water having its highest density, right? So it's like this. Then it's dropped like this manner, right? Then what happened? Rho ice, when it's also decrease in temperature from 4 to 0, once again the temperature will fall. Sorry, the density will fall, right? If it is a normal one, what will happen? Density will further increase, right? With the temperature decreasing. But with water, that the density is once again decreasing once it reaches maximum value, right? Either sides of the maximum value, the density is falling, right? Now rho ice is like 920 kg m minus 3, right? Okay. Kilograms per cubic meter. Then rho max is 1000 kilograms per cubic meter, right? This is the density values, right? Okay. You can clearly see that density of ice is much less. So Celsius 4 is the key factor where it has the maximum density of liquid water, right? Okay. This is how water fluctuate. If it is a normal substance, what will happen? This line will like this, as it representing the dotted line, right? It will continue in this manner. But for water, it's bended, right? So complete it. Complete it. Right. Then what will happen actually? What is the exact scenario? What is happening in a normal system? Now imagine this is a pond, right? Okay, this is a pond, right? So here the upper surface of water, and imagine now the environment is at minus 5 Celsius degrees, right? So ice is floating on the water top surface, and ice is at 0 Celsius, is the normal temperature. No? Now living species under the ice, that the water under the ice won't melt, right? Okay, sorry, won't freeze, right? Because that water will remain at around 5 Celsius. Then that will help for the survival of organism, because if the temperature goes, if there is no ice like this, ice formation is not like this, then the entire water will turn into minus 5 Celsius degrees. Then what will happen? Organisms will be died, right? Okay, so this ice just make sure that liquid water is still available, right? So the making ice cubes, so making the layer of ice which will make sure that liquid water is beneath that, right? Then organisms can survive. This is what happening now. This is a kind of temperature variation you can see. External environment minus 5, just an example, right? Temperatures might be different, right? But this is the value. So the minimum temperature is outside, then ice is having 0, and the highest temperature is beneath the ice layer. It means where the organisms are placed, right? Then it is easy for them to survive, right? Okay, nice. Then write down the final and the last one: versatility as a solvent. Final point, or the last point: versatility as a solvent. Versatility as a solvent. Write down: this ability is given to water. This ability is given to water. This ability is given to water due to their polarity. This ability is given to water due to their polarity. right? Okay. This ability is given to water due to their polarity. Underline polarity. Right? Then write down following substances dissolve in water. Following substances are dissolving in water, or following substances dissolve in water. Right? Number one, polar covalent molecules. Polar covalent molecules. Number one, type 1, polar covalent molecules, example glucose. Polar covalent molecules, example glucose. Right? Second one, ionic compound sodium chloride. Example is sodium chloride. The compound are ionic compounds. Number 2, ionic compounds. The example is sodium chloride. Third category, molecules with both polar and ionic regions. Molecules with both polar and ionic regions. Example, molecules with both polar and ionic, right? Examples, lysozymes. The example compound are lysozymes. Sorry, you have to change lysozymes, right? Is it there, right? Lysozymes, right? Okay. Then write down water molecules surround each of the solute molecule. Water molecules surround each of the solute molecules and form hydrogen bonds with them and form hydrogen bonds with them and form hydrogen bonds with them, right? Underline hydrogen bonds. Okay. Then write down next point. Therefore, solubility of the solutes depends on polarity and not and not and not in their ionic nature and not in their ionic nature. Solubility of the solutes depend on polarity and not in their ionic nature. Right? Okay. Right? So underline polarity. Right? Okay. Now write down. Now come to this part. Right? Okay. Now here we can see a certain particular molecule name as X, right? X is here, not your X, right? Okay, got it? Then water molecules surround that certain particular molecule, right? Okay, like this, it surround it, and what happens? It makes bonds with it, right? It makes hydrogen bonds with it. Then that's how the solubility is taking place, right? Okay, so hydrogen bonds mean not the bonds forming, actually that the polarity, that like ones, right? Polarity, polar molecules dissolved in each other, right? So then this will make the X molecule, these are water, right? Okay, so polarity is the fact which affect the solubility, right? Okay, by making bonds, okay, right? This will happen, this is what happening. Now the key factor, that is the polarity, is the factor. Polarity is the factor, right? Polarity is the factor. Okay, polarity is what therefore the main factor in dissolving, right? Now there are another two important points to write down after this. Use red pen, right? Write down. Water is the most abundant substance on the earth. Water is the most abundant substance on the earth. Water is the most abundant substance on the earth. Water is the most abundant substance on the earth. So underline most abundant. No need to underline, you have to write it in the red pen, right? Okay. Second point also write down. Water is the most abundant. Water is the most abundant inorganic substance on the earth. Water is the most abundant inorganic substance on the earth. So what is the most abundant substance? No matter in that, it means out of the inorganic ones, that is the abundant, and out of the all the substances, that is the abundant, right? So those two important points are very important, right? So done and dusted water. Wrap up the session. Now we are going to wrap up the session. Now I have to explain deeply and detail wise what is water and how it's important and its significance and its benefits towards the physical and chemical properties, right? So then this is what there for the today's session. Revision day 3 done and dusted. Water is completed. And from the next day, day 4, we'll come with carbohydrates. So we have to discuss about organic molecules. Now we are shifting from inorganic to organic molecules. As the first inorganic group, we are discussing about carbohydrates. So till then, stay safe, study well, and we'll meet with the carbohydrates. Till then, goodbye and good night. Okay.